Okay, so here we have two challenging questions that would have you thinking, basically. So let's take a look at the first one. It says find the first three terms. And then this one says find the 25th term. Now this is probably easy. I mean, if you watched my other video on sequence, you can probably do this. This one is a little different, and I'm going to take my time with this a little bit. So let's see how to do this real quick. Okay, so again, as we said, sequences, all sequences start with what? N equals 1. N equals 1. So you plug in 1 here, you plug in 1 here, you plug in 1 here. So you get 1, 1, 1. And as I said before in the last video, when n is 1, when n is odd, when n is an odd number, this term becomes negative. And when n is an even number, this term becomes positive. So in this case, when n is 1, this is negative. So 1 over 1 plus 1 is 2, so negative half. Here, n is even, so it's positive. Again, n is 2. 2 plus 1, 3. 2 over 3. Here, n is odd. Again, that's why it's negative. And then n is 3. 3 plus 1, 4. 3 over 4. We can continue going. Like, we don't even have to... The pattern is obvious. So the next one is going to be positive, and it's going to... n is 4, so it's going to be 4 over 5. Then the next one is going to be negative, and it's going to be 5 over 6. And then it goes on and on. Very simple. Now this one is a little challenging. I know, look at this. It looks like a mess. But let me explain. So it says find a of 25. So find the 25th term. Find a of 25. Find the 25th term. Okay. Obviously this would be stupid for us to do a of 1, a of 2, a of 3, a of 4, a of 5, all the way to 25. That will take hours, and you might still not even come up with the right answer. So we need to come up with a pattern, and then find a formula in terms of a of 1, and then solve for a of 25. That's the goal. So the goal is find the pattern. You can have an algorithm. Find a pattern. After you find a pattern, rewrite each term with respect to the previous term, and then you'll be able to generate a formula. So let's start with the first one. So let's find a pattern first. So when n equals 1, oh, I just drag that, come back. Good, okay. So when n equals 1, right? Look at this. When n equals 1, you plug in 1 here, you plug in 1 here, you plug in 1 right here, and then you plug in 1 here. So this is a negative because n is odd. Again, watch my other videos. 3 times 1 is 3. 3 minus 2 is 1. So negative 1. Simple. When n is 2, here, take a look at this. When n is 2, plug in 2 here, and then you plug in 2 here. So negative 1 squared is positive. That's why this is positive. And n is 2 here. So 2 times 3 is 6. 6 minus 2 is 4. Perfect. When n is 3, right here, this is odd again. Let's ignore all of this right now. Let's just ignore this. Let's ignore that. So when n is 3, right here, take a look at this. N is 3. Plugging 3, this is odd. That's why it's negative. Odd is negative. Whenever n is odd, this term becomes negative. This whole thing evaluates to negative. Whenever n becomes, if n is even, this term is positive. So let's see. So when n is odd, this is negative. 3 times 3, n is 3 here, 9. 9 minus 2, 7. Here, n is 4. N is 4. Take a look at this. 4. That's why it's positive. 3 times 4, 12. 12 minus 2, 10. So now we have negative 1, 4, negative 7, 10. So now, let's go back. Let's see if we can find a pattern. I want you to do me a favor for a second. Ignore the negative. Let's assume the negative is not there. I know it's there, but just ignore it for a second, okay? Let's ignore it. So now, let's see what we have. Look at this term over here. Can we rewrite 4 in terms of a of 1? When I say a of 1, this is a of 1. This is a of 2. This is a of 3. This is a of 4. Let's say it again. A of 1 equals negative 1. A of 2 equals 4. A of 3 equals negative 7. And a of 4 equals 10. So can we rewrite a of 2 in terms of a of 1? That's my question. So let's see. 4, if you take a look at it, we can do this by ignoring the negative value. Let's ignore this negative 1. Okay, let's assume this 1 is not there, right? If this 1 is not there, then if this 1 is not there, let's bring this back. So let me just erase this for a second. If this 1 is not, if the negative is not there, then 4 is the same thing as 1 plus 3, right? Yes. So now all we have to do is this. 1 is the same thing as a of 1, ignoring the negative. So this is a of 1 plus 3. That's how I got that. Make some space so you can see what I'm doing. So again, if you assume that the negative is not there, that's what 4 equals. 3 plus 1 is 4. If you assume that this negative is not there. Now you have a plus 1 is what? Is 3. A1 plus 3 equals 4, because we're assuming that A1 is 1. That was a little tongue twister. Let's go to the next one. Make space. Again, A of 3 is the same thing. You know what? Let's ask ourselves this question. Ignore this negative again. Is there a way to write 7? Write 7 in terms of 4. Can we do that? Obviously we could. Let's see. 7 is the same thing as 4 plus 3, right? But look at this 4. Does it look familiar? Yes, it does. It's the same answer as A of 2. You see that? 4 is the same thing as A of what? 2. So I can rewrite 4 and put what? A of 2 there. So 4 is the same thing as A of 2. So now I have A of 2 plus 3. You get it? Okay. Now, A of 2 is the same thing as what? A of 1 plus 3. A of 2 is the same thing as A of 1 plus 3. So I plug it in here. Now I have A of 2 plus 3. But since A of 2 is the same thing as A of 1 plus 3, I have A of 1 plus 3 plus this 3 outside. Now I have A of 1 plus 2 times 3, meaning there's 2 of the 3. There's 1 and there's 2. There's 2 of them. That's why I put a 2 here. Go to the next one. This is 10, right? Can we rewrite 10 in terms of 7? Yes, we can. Let me show you. 10 is the same thing as 7 plus 3. Now, look at this. Let's make space here. Does this 7 resemble something? Yes, it does. 3 plus 4 is what? 7. 7, 3 plus 4. So 7 is the same thing as A of 3, because 4 plus 3 is 7. This is why I replaced this 7 with A of 3, because 4 plus 3 is 7. So now remember, we still have a 3 here. Now A of 3 is the same thing as A of 2 plus 3. And A of 2 plus 3 is the same, and A of 2 is the same thing as A of 1 plus 3. Now we have 3 of the 3's. That's why I put a 3 here. There's 3 of them. 1, 2, 3. That's why I put a 3 here. So 3 times 3 is 27. Beautiful. Okay. We're not done yet. Now we're starting to see a pattern. I mean, 3 times 3 is 9. Sorry, not 27. Now we're starting to see a pattern. It is safe. Look at this. We have 4 here. Just take a look at this pattern. We have 4 here. We have 3 here. So 3 is less than 4 by 1. We have 3 here. We have 2 here. We have 1. We have 2 here. We have 1. So 2, 1, 3, 2, 4, 3. So it is safe for me to say that A of n equals A of 1 plus n minus 1. Because when this is 4, this is 3. When this is 3, this is 2. When this is 2, this is 1. So it is safe for me to say A of n equals A of 1 plus n minus 1 times 3. And that's how I got this. But that's not the full answer. Remember, I ignored all the negatives, and I got to bring them back. You don't just throw it away, you got to bring it back. So anytime you have alternating signs, anytime any sequence you see that has negative, positive, negative, positive, You always, I'm telling you this, always have to use this right here. This. Now, the way it differs is whether you use n or n plus 1 or 2n. It depends. It depends on the specific sequence. But here, this goes perfectly because when n is 1, it's 1 is odd. And I told you already that when you have odd, this becomes negative. Negative goes well with that. When n is 2, this is that's even, and this is positive, and that's it. So now we have a beautiful formula. All you got to do to find a of 25, which is what you're looking for, is plug in 25 for n, and then you solve it. Again, this is a little complicated. Pause the video at times. Watch how I solve it. Ask ask yourself, does this make sense? Does each step make sense? If it doesn't, all you have to do is leave me a comment, and I'll get back with you. Thank you.